Our lesson today is on lines, angles, and perpendicular lines. We'll learn about parallel lines, skew lines, and perpendicular lines, types of angle pairs formed by transversals, perpendicular line theorems. Eventually, you'll learn how to construct parallel and perpendicular line constructions. Parallel lines are defined in geometry as coplanar lines that do not intersect. Our example, line AB and line CD. Notice the arrows on the lines that indicates parallel on the diagram. Notice the symbol for parallel is shown here, along with using the little line symbols above the letters. Skew lines are two lines that are not coplanar and do not intersect. So these would be two lines in two different planes. Parallel planes are two planes that do not intersect. Perpendicular lines are two lines that intersect to form a right angle. You can see the symbol right here used for perpendicular. This says line AB is perpendicular to line CD, and we usually show a box in the corner right here of the intersection of the two lines to show they're perpendicular. In this example, we're going to name a line that fits each description. A line parallel to line TW, this line here, and contains point V. Now remember, parallel has to be in the same plane, so a line that would be parallel that contains this point in this plane, which would have to be the bottom, would be line UV. So we'll list it as a line UV. A line perpendicular to line TW and contains point V. So again, perpendicular would be a line going through point V. That would be this line here, VW. A line skew to line TW and contains point V. Skew again means that the two lines are going to be in two different planes. A plane again on a 3D object is each side of the object. So in order for it to contain point V, it would have to be line RV. Our last example, name the plane that contains point V and appears to be parallel to plane TPQ. Plane TPQ is the side over here. If it contains point V, it would have to be in parallel to the plane. It would have to be this one over here. Remember, we use three letters to name a plane. So in this case, we would have plane we use three letters, V, R, S would be one example of a way to name it. We could also name it VWS, again, any three letters to name a. Next, we'll take a look at angle pairs. We've already learned about vertical angles and linear pairs. Those will also apply to these problems. In addition to those, we have alternate interior angles. Those are going to be angles that are in between lines A and B. So think of interior means inside or in between on opposite sides of the transversal. So think of the word alternate means that they're going to be on alternating or opposite sides. So my example are angles 2 and 7 and 6 and 3. Consecutive interior angles are again between lines A and B because they're interior on the same side of the transversal. Sometimes people call these same side interior angles. We're going to refer to them as consecutive interior angles. So that would be angles 2 and 3 and angles 6 and 7. We also have alternate exterior angles. Those are exterior, which means outside, lines A and B, and alternating, so again they're on opposite sides of the transversal line. Those would be angles 1 and 8, 5 and 4. We have corresponding angles. Corresponding angles are either both above or both below lines A and B and on the same side of the transversal line. Sometimes people refer to them as being in the same position. So angles 1 and 3 are both above lines A and B on the same side of transversal line T. We also have angles 2 and 4, 5 and 7, 6 and 8. So again, here's our list of all the angles that are corresponding angle pairs. An example, list all pairs of angles that fit the description. Corresponding angles. So our corresponding angles again here would be angles 8 and 3, 5 and 6, 4 and 7, 1 and 2. Alternate exterior angles are outside of the two lines. By the way, they do not have to be parallel lines in order to have a transversal running through them. Alternate exterior angles are angles 8 and 2, angles 4 and 6. Alternate interior angles are going to be angles 1 and 3, angles 5 and 7. Consecutive interior angles are going to be angles 5 and 3, angles 1 and 7. We have a few theorems on perpendicular lines for you to write down. Theorem 3.1 says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Theorem 3.2 says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Please remember that perpendicular lines need to form one right angle by definition. So this is my linear pair right here, and these angles then are going to be congruent, means they both have to be 90, so these would be right angles here to make the lines perpendicular. Same thing in the second one. If we have a right angle and these are perpendicular, then these two angles have to have a sum of 90. Remember, complementary means sum of 90. Theorem 3.3, if two lines are perpendicular, then they form four right angles. Reminder, the definition tells us that there's one right angle. The theorem tells us that there are four right angles. Next, we'll take a look at the properties of parallel lines. These are all of the angle pairs that we just looked at in the last examples with the pictures, and tell us what about those angles. All of them, corresponding angles, alternate interior angles, alternate exterior angles, and vertical angles that we have listed in 1, 2, 4, and 5 are congruent. In other words, same measure. Consecutive interior angles and linear pairs are all supplementary. Again, supplementary means that the sum of two angles equals 180 degrees. Here's an example. If measure of angle 1 is 120 degrees, find the measure of angle 5. Angle 1 and 5 are corresponding. Always identify the type of angle first. If they're corresponding, they're congruent. That means the measure of angle 5 is 120 degrees. Angle 2 and 8. Angle 2 and 8 are consecutive interior angles. They have a sum of 180. If we take 180 minus 75, our other angle would equal 105 degrees. 4 and 7 are alternate exterior angles. They are congruent. So the other angle, 7, would be 30 degrees. 1 and 8 are not an angle pair listed. So what we can look at is that 1 and 5 are both 75 because those are corresponding. 75 for 1, 75 for 5. That would make angle 8, which is a linear pair right next to it, equal to 105 because they have a sum of 180. So angle 8 would be 105. Sometimes you have to look indirectly at the angle pairs to figure out. Next, we'll take a look at an example that doesn't use numbers, instead it uses x's. We identify the angle pair first. These two angles are corresponding angles. We know that corresponding angles are congruent. If they're congruent, that means the same as equal. We set the two expressions equal to each other. 2x minus 4 equals 6x minus 32. Solve for x. I'm going to bring the x's to the right. Negative 4 equals 4x minus 32. Bring the non-x's to the left, so I'll add 32 to the other side. Four x equals 28. Divide by 4. X equals 7. If we wanted to go back and find our number, we would put in 7 in place of x. Last example, we'll look at two sets of transversal lines. The first thing we identify is which is the transversal line with the two sets of transversals, and you can see A is parallel to B. We assume C is parallel to D on the picture. Which is the transversal line? The easiest way to identify it, the transversal line always lies along the two angles in question. So we have angle 2 and 10. Find the transversal line. Here's angle 2, here's angle 10. The transversal line is D. That means your parallel lines to look at go the opposite direction. A and B are the parallel lines. That would make these two angles corresponding. So they are congruent. So angle 10, 50 degrees. 3 and 5. 3 and 5 this time, if you notice, are here and here. That makes our transversal line this time line A. That would mean these C and D lines are my two parallel lines. 3 and 5 are alternate exterior angles which are congruent. So this would be 75 degrees again. Fourteen and 1. Again, we'll identify here's 14, here is 1. Our transversal line this time is C, that both of these lie along. That means that these two angles are also alternate exterior angles, which means they're congruent. This would be 105 degrees. And finally, we have 15 and 2. Angle 15, which is this angle over here, and angle 2, which is the angle over here, are going to have a consecutive interior pair of angles. Transversal line is A. That would mean these two lines are parallel. So these are supplementary because they're consecutive interior. We subtract from 180, we get 70 degrees.